Welcome learners to your natural science lesson, and today we're going to be doing some practice questions based on pure substances and mixtures. So let's begin. We have a picture here, we have pictures here, and then we need to decide if whether any of these are elements, molecules, compounds, or mixtures. So what are elements, what are molecules, and what are compounds? We know that elements, we can find them from the periodic table. They are made of the same type of an atom. And then molecules, they can be made from the same type of an atom, or they could be made from different atoms. And then a compound is made of two different elements. And then mixture, those ones we can either have mixtures of elements or mixtures of compounds that are together in the same place but not chemically bonded. So with that in mind, let's see if whether we can be able to identify these pictures here. So the first one, we have blue and we also have red. They are not chemically bonded. So therefore, this is going to become a mixture. So A is a mixture. B, we only have red that's within that picture. So it's made of the same type of an atom. So therefore, that's going to be an element. And then we have C, the next picture, where we have the molecule that is blue and the other one that is red, and they are both chemically bonded. And if they are chemically bonded, that becomes a compound. That becomes a compound. Now remember that the difference between these two pictures is that this is of the same type, and then these ones, they are made from two different substances. So therefore, this is a compound, and that's an element. Right. Moving along to the next one and see if whether we can be able to do that. So we also have again here A, B, C, and D. We need to identify if whether these are compounds or mixtures. So the first one, those are two different substances combined, chemically combined or chemically bonded together, and then they form a compound. And the second one, we also again they have two different substances chemically bonded together. We see that the red is chemically bonded to the white. And if they're chemically bonded, it becomes also a compound again. C. Then we see that there we have a red that is bonded to another red, so it's of the same type. Then also have white that is bonded to another white, also of the same type. But the red and the white are not bonded, so that becomes a mixture because they are not chemically bonded. Then maybe you want to take it further, you can say that this is a mixture of elements because we have two elements that are in the same place. Then D, we have the red, and we also have another red that is bonded to the white. So this is a compound, and that's now our atom there, or our element. However, these two, or this and this, are not chemically bonded. If they are not chemically bonded, it means we can separate them easily. And if we can do that, it means it is a mixture. It is a mixture. This compound is a mixture. Right. Now, as we move along to answer other questions, I hope you understood and it was clear. We are faced with another question here again, whereby we are asked, are these elements compounds or mixtures? So we have tap water and distilled water. Now we can see here that we have different things. We have the red, we have the blue, we have the green, and the blue, and the yellow, sorry. And none of those are chemically bonded. So now that becomes a mixture. So this becomes a mixture. And then here, the distilled water. So now distilled water, remember that water is a compound that is made up of oxygen and two hydrogen atoms. So distilled water is still water, and water is a compound. So therefore, this is our compound. Now, moving right along. With what we know, let's see if whether we can be able to complete this table. So we are given an example there that seawater is not an element. It's also not a compound, but is a mixture. So seawater is a mixture of different things. And those things are not chemically bonded. So it becomes a mixture. So sugar, is sugar an element, a compound, or a mixture? Sugar is not an element. No. And sugar is not a mixture, which then means that sugar is it is a compound. So our next substance is distilled water. We need to decide if whether it's an element, a compound, or a mixture. So for the fact that it's distilled water, it means they've removed some impurities. So what is left is just pure water. And we know that water is a compound. So water, distilled water, it is a compound. So yes, so it's no longer a mixture, and it can be an element because it is a combination or a chemical bond between hydrogen and oxygen. Then our next one is tap water. So tap water can't be an element because there's water there, so it's not an element. Now, because tap water has some impurities, they've used some chemicals to clean that water that you drink, so therefore it can't be a compound. It is going to be a mixture of other things with that water. So therefore it's not a compound, but it is a mixture. So yes. Then the second last one, copper. Remember, if we can find it in the periodic table, it's an element. So copper, yes, we can find in the periodic table. It's not a compound, also not a mixture. So it is not a compound, not a mixture, but it is an element. And then the last one, diamond. Diamond is an element made from carbon. So therefore, it's not a compound, it's also not a mixture. So this one is an element. It's not a compound, also not a mixture. So diamond is made of carbon, and we can find carbon from the periodic table. So it makes diamond to be an element. Now, next question. We are given this particular compound and we are asked to, it says the question, how many atoms of each element are present in one molecule of? So from this particular element that we have here, from this particular compound that we have here, we need to now know how many atoms or how many elements are present in this molecule. So we're seeing that we have the first part, NH4, and then there's a bracket there, the 3, the subscript 3. So now that 3 means that everything within the bracket is multiplied by 3, which then means we have 3 nitrogens, and then because already here we have 4 hydrogens, that 4 is also going to be multiplied by the 3, which then means that's going to be 12 hydrogens. Then we move on. The PO4, it is not within the bracket, so therefore those ones, they are counted individually. We are not multiplying anything there. So we just know there that we have 1 element of phosphorus, and then we have 4 oxygens. So therefore, now answering this question, it says, how many atoms of each element are present in one molecule of? Nitrogen, how many do we have? We said there, 3. Hydrogen, we have the 12 because we said 4 multiplied by the 3. And that nitrogen, we said there's a 1 here, there's a 1 there, 1 multiplied by the 3 is 3. And then 4 multiplied by the 3 is 12. So we have 12 hydrogens. Then the phosphorus, as you see, we only just have just that 1 phosphorus, so it's just going to be 1. And then the oxygen, we have 4 of them. It's not multiplied by anything, so therefore we have 4 oxygen. I hope you understood, and I hope it was clear. And let's just quickly take an ad break. I'll see you just after this.